So for this problem, we're asked to develop the parabolic equation that describes the curve at station 36 plus 50 and determine the low point, station, and elevation. So we're going to look at those components for this problem. So this is the curve at station 36 plus 50. That's the given PI station. We also have elevation, vertical curve length information, our K value, which is the rate of vertical curvature, and our design speed. We also can see our entrance grade, G1 is negative 8%, and our exit grade, G2 is positive 6%. Another thing to note, there is a typo on the vertical axis here, so we should see 10-foot increments, and these the values shown in red are the corrected elevations for that axis. So again, G1 is negative 8%, G2 6%, both those were shown on the drawing. The length was given as 900 feet, and that is 9.5 stations. For our parabolic equation, we need to use percents and stations. Percents for the grades and stations for the lengths. The PVI station is 36 plus 50. The PVI elevation was given as 997.88 feet. We can determine the PVC elevation by looking at the distance and the grade from the PVI elevation. So it's PVI elevation plus half the length of the curve times the grade negative G1. So we have 997.88 plus 950 divided by 2 multiplied by 8% gives us an elevation of the PVC of 1,035.88 feet. For our parabolic equation, generally it's y equals ax squared plus bx plus c, which equals g2 minus g1 divided by 2 times L times x squared plus g1 times x plus the PVC elevation. So now starting to plug in our values, y equals 6 minus negative 8 divided by 2 times 9.5 times x squared plus negative 8 times x plus 1035.88. That simplifies to 0.736842 times x squared minus 8 times x plus 1035.88. Now we can find the location of the low point. This is the distance from the PVC. X equals negative G1 times L divided by G2 minus G1 equals negative 8 times 9.5 divided by 6 minus negative 8 equals 5.4285, which is equal to 542.85 feet. So this is telling us that the low point happens a distance of 5.4285 stations from the PVC, and again that's equal to 542.85 feet. So the station of the low point is the PVC station plus x, so this equals 3175 plus 542.85 gives us a station of 37 plus 17.86. The elevation of the low point, we just need to plug in our x value into our parabolic equation that we solved for previously. So y equals 0.736842 times 5.4285 squared minus 8 times 5.4285 plus 1035.88 gives us an elevation of the low point of 1014.166 feet. So showing this information back on our design plans, the parabolic equation that describes the curve that has a PVI at station 36 plus 50 is y, which is the elevation, equals 0.736842 times x squared minus 8 times x plus 1035.88. X is bounded by the PVC and the PVT, so x has to be between 0 and 9.5. So it can't be longer than the curve. You cannot use this equation to estimate the elevations outside of the curve. It's got to be between 0, which is our PVC, and 9.5 stations, which will give you the PVT elevation of the curve. And we can find any point in between. So again, the low point we found was at a station 37 plus 17.86. And the elevation of that low point was 1,014.166 feet. We used the parabolic equation to find that elevation, and we used our equation for the location of the low point to find that station of the low point. So this solves the problem. We have our parabolic equation and our station and elevation of the low point.